Good morning and good afternoon to everyone. My name is Claudia Ringler and I am the Deputy Division Director at the Environment and Production Technology Division of IFPRI. I'm also linked with the CGIAR research program on waterland and ecosystems and with the Bridge Collaborative, all of which you'll hear about today. I would like to welcome everyone to today's policy seminar on the role of the agriculture ecosystem health interface in addressing zoonotic disease risk, such as COVID-19. Several past and recent IFPRI policy seminars focused on the human impacts from COVID-19, such as reduced incomes, job losses, interruptions in local and global food value chains, and nutrition impacts. However, it is also important to look at the role of agriculture and food systems in preventing zoonotic diseases. Should we focus on, for example, yet better nourished people to stave off disease risk and reduce the need to rely on wildlife protein? Change to diets without livestock products? Or should the food system instead focus on reducing climate change, as this might be the biggest contributor to future zoonotic disease risk? These questions are particularly important as a recent review suggests that agriculture drivers were responsible for more than 50% of zoonotic diseases that emerged in humans. So clearly, agriculture has a role to play to reduce such diseases. Discussing this is not only timely because of COVID-19, but also because CGIAR, the world's largest agriculture innovation network, is currently developing a new research strategy to meet its vision of ending hunger through science to transform food, land, and water systems in a climate crisis. Depending on the science developed and employed, these systems can be transformed for both human and wildlife needs. Where should science focus on? To get at these issues, we will now hear from 4 speakers and 3 discussants who will each address a little piece of this very large and interconnected puzzle. Before I'll introduce the first speaker, I'd like to remind our audience to please add your questions to speakers in the chat box, as soon as they come to your mind. Feel free to nominate the speaker you would like to respond to your question. And without further ado, I would like to introduce our first speaker, Christian Balzer, who is the Executive Director of Wildlife Health at the Wildlife Conservation Society. He will give us an overview on zoonotic diseases and food system linkages. Thank you very much. Welcome, Chris.
Good morning, everyone from the Bronx. I hope you're all staying healthy, safe, and sane. And thanks very much for the invitation. Zoonosis and zoonotic origin are diseases obviously that move between animals and humans. It's nothing new. As we domesticated livestock, we acquired many diseases. Some of those are well known and we've made them uniquely our own, such as measles, for example. And these emerging infectious diseases are dominated by zoonosis. Those are the ones we're particularly interested in. And nearly 3/4 of them originate in wildlife. One thing that's really important to note is that the frequency of emerging infectious diseases such as HIV, Ebola, the various influenzas, Nipah, Hendra, and so on, is increasing. There's really only one way to look at this. Even when you correct the data, there's about 50 outbreaks per decade, and that rate is increasing. And I think one of the most impressive ones, and you will hear more of this later, there've been 11 outbreaks of Ebola in the DRC since 1976. 8 of those occurred in the past 13 years, and just in the past 2 years, 4 of them have occurred. And as you know, unfortunately, there is a new outbreak ongoing at the moment in the eastern DRC. So let's look back at SARS coronavirus 2 and what is known. Well, I think there's a broad consensus that it's a zoonotic origin pandemic. I think we can all agree on that. The ancestral host at some point in time was in a horseshoe bat. There's nothing surprising there at all. That is similar to other coronavirus that we've seen, such as SARS and MERS in recent years. What's really unclear at the moment is the time, place, and the mechanism of the spillover. There's quite a strong signal from the market in Wuhan as some kind of, you remember the market in Wuhan is a place where wildlife was traded, and there's a signal there from environmental samples. Unfortunately, they're of low quality, and we don't really know much about these environmental samples. So generally, the information is lacking. One thing that's important to also understand, for those of you who are already working in this field in 2002 and 2003, one of the things that has really changed is the interconnectedness of people and goods moving on a global scale. Just to put it in context, in January, it was estimated there were some 700 people moving from Wuhan to New York City every single day. And that's obviously something that has changed massively. So in summary, it's not really about bat soup, civets, or pangolins at all. It's all about interfaces. You could look at this photo and you could say, well, that's a road that goes from A to B. But along those, one way of looking at it, these edges of destruction cutting through the forest create interfaces. These are interfaces where pathogens, which are naturally, or potential pathogens, I should say, naturally circulating in wildlife on the forest edges, are provided an opportunity to spill over into humans and their livestock. And as we have these roads, which then move to ever increasing urban centers, we're able to, and the viruses and pathogens acquire the traits necessary to transmit between humans. We get the makings of a small epidemic outbreak, or in this case, a pandemic outbreak. One thing though to be aware, there are many natural barriers to stop viruses spilling over. It is not simple, and it doesn't happen that often, thankfully. And especially for the spillover to result in human-to-human transmission. That is a very rare event, but when it does happen, as we see now, the consequences are massive. One of the ways also things to be aware of is that we can't address this on high-risk species, low-risk species, on a virus. Let's just look at coronavirus. It is estimated there are about 1.7 million unknown viruses, of which 700,000 have potentially zoonotic potential. So for every one of our coronavirus, there are thousands more that we know very little about. So one of the things in this context that's really interesting is the wildlife trading markets, and especially the ones that trade in live wildlife in Southeast Asia. When you start stacking live animals on top of each other, and they're basically pooping on each other, they're being slaughtered on site, you're providing perfect conditions for new recombination events to occur and new viruses to emerge. Obviously, you're throwing in thousands of people into the mix as well. So that's a perfect situation. And remember, these markets are large, industrialized, complex with hundreds of wildlife species mixed together. Nothing like small stalls in some forest somewhere in Central Africa. It's not only about the market, there's a strong focus, it's along the whole trade chain and all the contact points along that trade chain. Just recently, we've looked at the trade in field rats in Vietnam and looked at coronaviruses. Basically, in summary, it's better to eat your rat in the field. There's only 1 in 5 chance that it will be positive for coronavirus. As you move along that trade chain and reach the restaurant or kitchen, every second rat is going to be coronavirus positive. So that's quite an important fact to understand how amplification happens along this trade chain. Now, COVID-19 is obviously just a symptom of ailing planetary health. Combined with other, and more importantly, climate change, we're seeing that we need to address human, animal, plant, and environmental health in a more holistic, in a One Health approach. This is easy to say, much more difficult to operationalize. We also need to really be aware, where are the front lines of spillover? Are they really somewhere in Africa, or are the front lines just somewhere else? Is it capital which is driving some of these changes in spillover events? Most expedient from our point of view is to permanently ban the commercial trade of wildlife, live wildlife in urban centers being the most important. Obviously, we need to address illegal trade, but that is not the point. Viruses do not care if it's illegal or legal. And we need to change the consumptive behaviors while clearly recognizing that we need just solutions that meet the rights and the needs of those indigenous peoples and local communities that are dependent on these wildlife resources. Thanks very much for your attention.
Yeah, thank you very much, Chris. I think a very great overview of zoonotic disease risk and already several linkages with agriculture and food systems. So that road through the through tropical forests, which stimulates agriculture and economic development, might stimulate a lot of other things. And of course, I think you did quite a bit refer to the actual consumption, the direct consumption of wildlife, which is a part of our food system. And I think you very clearly suggest that should not be a part of our future food system. So now we move over to our second speaker, Ricky Robertson. He's going to talk about land use change, agriculture, climate change, who is really responsible for such land use change. And just please remember again, any questions you might have to any of our speakers, please add them to the chat box. Thank you very much.
Greetings. So the traditional story that we're working off of here is that land is in demand by both people and natural ecosystems. In simple form, it's like a staircase. We start with some combination of more or richer people who eat more or better food. Can we go to the next slide, please? Producing the food takes up space on the ground, which then displaces forest, which destroys habitats for other animals who then come into close proximity and conflict with people. That increases the risk of diseases moving back and forth, which can come back to hurt those more prosperous people that we started with. But to figure out how big a deal this is, we need models that can handle the numbers. At IFPRI, we have a detailed model of the global agricultural economy called the impact model. And recently, we've added a new set of tools that allow us to look at the land on a location by location basis instead of at the country or river basin level. Next slide, please. When we put everything together, what we found was a little unexpected. We found that climate change will probably disrupt forests more than incursion by cropland. Yes, cropland will expand to fulfill the needs from that staircase in the previous slide. In fact, it will need just shy of 20% more area than it currently occupies. To put that in global perspective, that is an extra 1.8% of the total land surface available in the world. About 90 or 95% of that new land is needed because of these demographic and economic drivers. The other 5 or 10% is because climate change hurts yields. But when we put the different kinds of forests together, about 1/8 of the total area is lost. This corresponds to 3.1% of the total land surface in the world. So since 3.1% is bigger than 1.8%, more forest is being lost than could possibly be displaced by cropland expansion. Well, of course, some of that forest is being displaced by cropland, so perhaps we could abandon that part and grow forest instead of crops. For cropland, that would put us about 8% below the 2005 amount of cropland. But even with that drastic reduction, completely disengaging cropland and forest, we only reclaim 2.6% of the land surface for forest, and that is still smaller than the 3.1% we would need. Even if we are somehow able to keep the overall number pretty close to where we started, there's a lot of moving around for the forest. The little map shows how the likelihood of forest changes at each location. All that red and yellow means that the forest is leaving or is becoming unhealthy, while the blues and greens are the increases. That pixel level specificity allows us to see how important cropland changes are for forest changes. For example, in Africa south of the Sahara, the projections show a need for cropland in 2050 that is half again as large as the recent past, as opposed to the 1/5 extra for the world as a whole. It also sees a 1/5 decline in forests as opposed to the 1/8 for the rest of the world. In absolute terms, more cropland is being added than the amount of forest being lost. However, when looking at where those changes are taking place, the new cropland is being added in different places than where the forest is declining. Next slide, please. Now we come to the infamous question. But what is the policy implication? How can we reduce the conflict between agricultural activities and natural ecosystems to in turn reduce the risk of passing diseases back and forth? First, we need to minimize cropland incursion where the fast and intense conflict will occur. The most obvious approach is the Boerlog plan. Crank up the productivity of land fast enough that we do not need as much to still eat well. I think that we need to look more broadly than the strict better seeds and more fertilizer from 50 years ago. Yes, we definitely need those things, but we also need to think in terms of institutions and infrastructure for farmers. The whole point is to not have as many people in close proximity to or displacing the natural ecosystems, but they still have to be somewhere. Those people should have opportunities to build happy, prosperous lives in other physical locations while pursuing activities that are not strictly primary productivity. Second, even if we completely remove the agricultural pressure at the local level, climate change will slowly but surely cause trouble at the global level. So we have to deal with that larger issue in a way that can slow it down and hopefully enough to allow the natural ecosystems to evolve and adapt to the new circumstances. Third, in our model, cropland locations moved around, but seem to be much more stable than the forests. That invites the question of whether there is a stabilizing role for agriculture. Can agroforestry systems use agriculture to keep at least some forest in places where it would otherwise be expected to disappear? Can active management of forests slow their departure and preserve habitat for animals so that they do not come into as much conflict with people? These are tough interdisciplinary issues. They are also diffuse across borders and jurisdictions without much clear potential for financial profit. That means they are unlikely to be taken up by private actors or even individual governments. So, in order to understand what's really going on and what things will work or will not work in response, it will take a broad collaboration in the international style, much like what the CGIAR has done in the past, but conceived even more broadly. Thank you, and now back to Claudia.
Yeah, Ricky, thank you very much. I think you put up a whole series of questions from, we'd like probably to hear from all of our presenters what their thoughts are here. So should we focus on reducing agriculture's contribution to climate change, or should we focus on so-called zero further forest incursion through croplands, or should we actually just use agriculture to grow more trees? So I think those are great points. We'll now move on to our third speaker, who's John Fa. He's a senior research associate at C4, with one of the CGIAR centers, and he's also professor of biodiversity and human development at Manchester Metropolitan University. And he'll talk about the forest, wildlife, food system interlinkages. Thank you very much. John, please.
Thank you very much, Claudia. I think what's very important from my point of view is to reassure everyone that we are coming from a different angle. And I think this is vitally important because we can have a richer discussion about the whole issue of land use, humans, infectious diseases and all that. Our particular role, our focus for a number of years now within C4 has been to try to understand the use of wild animals in tropical rainforests throughout the world. And in so doing, we address the issue of food security, livelihoods and incomes from the sale of wild meat, but also we have started looking at the whole issue of the interface between diseases that are spread allegedly by animals. Of course, there are some cases where that's the case. And also the use of that resource that a lot of people actually use. Research has actually taken us to all the areas throughout the world, but in particular we've focused on the whole issue of Ebola. Can we actually predict the spread or the actual areas where Ebola is likely to occur by using sort of modeling systems that will allow us to pinpoint areas which are likely to be hotspots of the spread of the virus. And together with the University of Malaga, biogeographers, in essence, we have actually come up with new models that allow us to determine the potential distribution or distribution area of Ebola. And that's what you were seeing in this particular slide. This is a paper that we published a couple of years ago, 3 years ago, in fact, and we can now tell, using a series of variables, including the likely animals, the animals that are likely to spread the Ebola virus, we can actually tell you where the highest probability is of transmission of the virus to animals and, of course, to humans. And what we see very clearly from this particular map is that there is a very strong correlation between the distribution of rainforest in Africa and the presence of the Ebola virus. If you look at favorability of conditions, Ebola virus is essentially one that occurs primarily in rainforest areas. Our preoccupation working with bushmeat, wild meat, and the use of wild meat was, is there any evidence that there are particular species or groups of species that could be spreaders of the disease? Maybe reservoirs, maybe vectors, maybe amplifiers of the virus itself. And through a series of biogeographic analyses called chorotypic analyses, we have managed to come up with ideas of where these likely groups of animals are distributed and how they can actually spread the disease. And in fact, very much linked to the overall distribution of Ebola virus like we showed you before in the last slide. The preoccupation, of course, was also to try to assess whether there is any evidence or any correlations between the deforestation, forest loss, and the risk of Ebola virus transmission. We did a number of studies, including C4 and many other institutions, that looked at the time lag of deforestation before the outbreaks of EVD throughout time, since 1976, as Chris mentioned. What we do show very convincingly is that there's a very strong correlation between deforestation 2 years before the event of EVD and EVD. So what we show quite conclusively is that deforestation, as has been mentioned by the other speakers, is a very strong driver of Ebola transmission. And our work actually shows that very clearly through a series of time lag and understanding. We can show that there are areas that are much more prone for Ebola transmission, and these are very much actually promoted by deforestation itself. But deforestation on its own can't actually explain the spread of Ebola. And one of the things that, again, we have done using biogeographic analyses is look and see the association between the potential groups of species, in other words, sort of fruit bats in Africa, how likely they are to be associated with human disturbance and deforestation. And the long and the short of the story is that there's a very clear correlation between the human disturbance, deforestation, and the presence of certain species, primarily those 5 fruit bat species that have been linked in some sort of way serologically to the Ebola virus. The other very interesting and unfinished work that we are doing is actually looking at whether atmospheric oscillation indices are actually in any way linked to the EVD outbreaks that we know since 1976. And again, what we do find is that after looking at about 31 different indices, we can show that the Pacific oscillation, decadal oscillation, is very much linked to the outbreaks. And we can explain certain proportion of the variation in the outbreaks by that oscillation. what we are saying is that we have a series of information now coming in from different angles that have got to allow us to come up with tools for prevention and response. And the challenge now is how we can actually bring all that pieces of information to come up with a realistic early warning system that can allow us to say these areas are much more prone for Ebola, and maybe any other disease. We can do the same modeling for other diseases and actually come up with a realistic early warning system that can then say, we need to have a look and prepare ourselves for potential outbreaks. And we're talking Ebola, but I'm sure that the modeling and the system can actually be applied to many other diseases. I do believe, like others, that this is something that has to be done through international collaboration. The early warning system is a tool, a research tool, but can actually be applied and used on the ground by those people who are dealing with the day-to-day living of producing enough food for people to survive in the long term. So our story is very much how can we use a series of elements in our research to come up with a prediction tool that can allow us to, ensure that things are going to be better in the future. Thank you.
Thank you very much, John. So another interesting angle. So actually predicting, zoonotic disease risk through modeling. So I think that obviously is something that CGIAR likes to do. And obviously, I think the other point that I heard is to really deforestation itself is the critical, tropical deforestation is a very critical challenge, and how ag and food systems can obviously be changed to stop that, at least from that angle. I think that sounds like another important message for us. We now will hear from our last speaker, Catherine Kreis. She is the Director of Strategic Initiatives and Lead for Nutrition Innovation at PATH, and she's also a Bridge Collaborative Secretariat member. And she will talk about a completely different angle and a different potential solutions to address future zoonotic disease risk. And her entry point is on cultured proteins. Catherine, please.
Well, good morning, afternoon, or evening to everyone, and thank you so much for the opportunity to be here. As Claudia mentioned, I'm going to talk about sort of some of these next generation technologies for food production and what some of the implications are in terms of improving health, development, and environmental outcomes. These new technologies are really going to help to meet the demand, or the growing demand, for higher quality diets that are being recognized because of increased incomes and growing populations. And most of that higher income diets are going towards animal source foods. So really trying to look at some of the interesting implications for that. This work was conducted under the rubric of the Bridge Collaborative, which is a collaborative that was set up to really rethink the way that we look at how we approach problem solving, to be more in line with looking at health implications, development implications, and environmental implications at the same time. So that intersection between people and planet. And it was funded by the Rockefeller Foundation. Next slide, please. So I wanted to talk a little bit about cultured proteins. And before I began, I thought maybe I would just let everyone know what those are. There's a lot of mixed language around this. I think we haven't yet really identified some of the intricacies of the language. So I think what I'll do is just try to set the stage by talking a little bit about what cultured proteins are. And cultured proteins are really produced through cellular agriculture. So cellular agriculture is broken down into sort of two types. There's cellular agriculture and acellular agriculture. Acellular agriculture is really the ones that are producing things like meat, and those are not quite on the market yet. But cellular agriculture is really using large-scale fermentation. So just like brewing beer, you sort of take a sugar, You add a genetically modified yeast or microflora, and that produces a protein. And then you spin the catalyst or the GMO catalyst out, and you end up with a pure protein. Next slide, please. So this work really was a series of things that we were looking at in terms of trying to figure out what the implications are for uptake and impact of these new production technologies and their resulting products. And the work had 4 components. The first one was a market analysis. So we were very interested in trying to figure out what kinds of markets are there for milk and egg proteins in this case. And what those markets might indicate in terms of the potential for uptake of new products. The second piece was looking at the enabling environment, so the policy regulatory environment, as well as things like designations for vegan, halal, and kosher. And that was really trying to get a sense of what does the policy regulatory environment look like for these types of products in countries that might be producing them, that may be procuring them, and then maybe consuming them. And of course, there's always a lot of overlap between those, but the policy regulatory environment is important to understand if you're trying to move those new products into markets. The third set, which is maybe one of the most interesting pieces, is pending publication. So I'm not going to talk too much about it, but it's really trying to get at the implications for market uptake and the implications of these new production technologies on health, which was led by PATH, agriculture, which was led by IFPRI, and environment, which was led by Duke. And I will talk a little bit more about that a little bit later. And then finally, we also wanted to look at the potential to develop a carbon offset model for these new production technologies, because it would really play into a business's bottom line in terms of thinking about market uptake. Next slide, please. So the first piece that we looked at really was this market landscape analysis, and I just would like to highlight a few of those key findings. One is that the milk and egg market size is very large, and consumption varies quite dramatically by country income levels. So high income countries consume roughly 6 times more milk products per capita and 9 times more egg per capita than low income countries. Detailed dietary guidelines and government initiatives, school programs, marketing campaigns, income, and lobbying efforts are factors that likely contribute to higher rates of dairy consumption in high income versus low and middle income countries. Milk is currently used as an ingredient in a small number of food aid products, though there is the potential to expand the use of milk in food aid products more broadly to increase protein content. And of course, particularly for young children, those higher quality proteins or those complete proteins that you find in animal source foods like milk and egg are very important for human growth and development. And we think there's probably a market entry point into relief and development foods in low and middle income countries to improve the quality of those foods. And then finally, in high income countries, sales of plant-based alternatives to milk, eggs, and other animal source proteins are really rapidly expanding every year, which we think indicates a demand for alternative animal source proteins. Also, the cultured protein market is very much at a pivotal phase, with products already beginning to be on the market. So in fact, the first one is this ice cream that was produced by a company called Perfect Day that used for the first time these proteins, milk proteins that were produced through acellular agriculture. And then most manufacturers we found are formed their companies, say, within the past 4 or 5 years. So this is really a growing area of interest. And most manufacturers are initially aiming to price their products at parity with existing milk and egg products, but they acknowledge that further price reductions are possible once the products are being sold at scale. Also, stakeholders had positive perceptions of cultured proteins for use in low and middle income settings, but they were concerned about the price. Next slide. The second piece that we worked on was around the enabling environment, and we found that the industry is rapidly evolving. So many manufacturers are anticipating near-term product launches and are in active conversations with regulators in multiple countries. We looked at multiple potential regulatory pathways, and we found that there are several that exist and will depend on the final products that are launched. So we looked at countries that were likely to produce, procure, and consume. In the United States, we have the most clearly defined regulatory pathway for cultured milk and egg proteins, and cultured proteins will likely be regulated in the US by the FDA under the generally recognized as safe framework. And although multiple potential regulatory pathways exist in the EU, India, and Ethiopia, which were some of the countries that some of the areas that we looked at as case studies, there's really no clear determination that has been made at this time. And where food safety institutions and regulations have been established more recently, it's likely that the regulatory approaches in high income settings may pave the way in informing other countries' regulation of these emerging products. And finally, GMO considerations will vary by country. So we know that there is quite a bit of interest in looking at the GMO issue. In the case of cultured proteins, those are the catalyst that contains the GMO piece of it is actually spun out at the end. So there is no GMO in the final product, but it is used within the production process. Next slide, please. And finally, just to give you a taste of what's coming on the impact modeling and carbon analysis, we found that modeling indicates that new production technologies for cultured milk proteins could have implications for health outcomes such as stunting and respiratory deaths, agricultural outcomes, including crop area and water consumption associated with dairy production and other environmental outcomes. And cultured milk protein production has lower greenhouse gas emissions footprint than traditional milk, and the differential in greenhouse gas emissions is sufficient to pursue further investigation of carbon credit generation. And finally, while we didn't explicitly look at cultured proteins, we do think that they could probably help reduce zoonotic diseases, as well as other issues associated with antibiotic resistance and hormone use, when we're thinking about these technologies in terms of the livestock value chain. Thank you.
Yeah, I think, Catherine, thank you very much. Very interesting research, and I think very relevant for the question of how agriculture and food system can contribute to reduce zoonotic disease risk. Even so, the research was not necessarily initially, conceptualized to address zoonotic disease risk, more in terms of environmental footprints. So now we have heard from our 4 speakers, and I'd like to again remind the audience to put all of your questions, bring your key questions, thoughts, put them into the chat box. So we will soon approach the Q&A portion of the session, and we will try to address as many questions as possible. But before we get to that, we will hear from 3 discussants who will bring in yet different perspectives and other pieces of the puzzle. So we'll first hear from Isabella Cosiel. She's the director of the CGIAR research program on water, land, and ecosystems. And so this is the only program in CGIAR that has ecosystems expressly in the title. And so we look forward to hear her short comments on this topic. Thank you very much. Please, Isabella.
Thanks, Claudia, and greetings all. So thank you for also a very interesting set of presentations, which I think really highlighted the extent of the challenge, but also the potential for change in the future. And it's a very well-known fact, we know it all, but I will say it again, that we radically and urgently need to change our relationship between food production and the ecosystems that support it. We've had numerous reports over the last 10 to 20 years expressing and espousing that need. We've probably reviewed about 20 reports, 50 reports over the last 20 years, but how are we going to actually achieve this? We have an exponential growth in demand for food with the same old policies, technologies, and institutions, which not only have created the risk that we've heard about today from the presentations, COVID-19, but also exposure to new risks such as climate change. And the inertia and investment in these various agricultural models is so significant. How can we change this? This is not an easy task. And so here in our program, the Water, Land and Ecosystems program, and in the CGIAR, we believe that we need to focus on a different kind of innovation and set of innovation processes that will help us build back better after COVID-19 or build a better future. Recent Nature articles stated that research is behind schedule on these issues. Why can't we get there? So the CGIAR, as Claudia mentioned, there is a new research agenda for 2030. And this research agenda is really going to focus on an integrated approach to food, land and water systems. Language such as systems transformation, resilience, trade-offs, that is going to be part of the new CGIAR agenda. I'm not saying that that is going to be an easy task moving forward. But in our program, we are actually going to look at what kind of innovation do we need for the future? And we've set up a commission to explicitly look at these issues. But we've also been looking at and lobbying for a radically different approach. And I'm going to just share 3 areas with you today that we've been focused on. One is really about increasing dietary diversity, moving away from a focus on carbohydrates. Of course, they're important, but we need to change our dietary patterns. And secondly, a modern approach to sustainable intensification and agroecology. Let's not romanticize those approaches. Let's move forward and integrate them. And finally, bringing in better returns for multifunctional landscapes. We still don't have the right business models for these landscapes. We really need to develop new ways of moving forwards and developing solid income streams and value chains from landscapes. Thank you.
Yeah, thank you very much, Isabella. You really broadened the field here. So we've now heard changing dietary patterns, modern agroecology, real use the advantages of multifunctional landscapes. So great additions. So we now move on to our second discussant, who's Josh Goldstein. He is the director of the Bridge Collaborative, and he's also with the Nature Conservancy. Thanks, please, Josh.
Thanks, Claudia. As Catherine briefly described in her comments, the Bridge Collaborative is a global platform working to deliver more integrated evidence networks and solutions across the environment, human health, and sustainable development sectors. And we're led by 4 organizations: the Nature Conservancy, where I'm based, IFPRI, of course, the host of the seminar, PATH, where Catherine is based, and finally Duke University. And integration is really at the heart of what we do. And that ranges from working with project teams to test and scale cross-sector solutions, to helping organizations prepare their staff to have the skill sets and networks to work across health, development, and environment. And finally, to engage leaders and funders to unlock more resources and tangible support to deliver integrated impact. And I'll use those areas of focus to guide my brief comments today. As earlier presentations have shown, the pandemic drives home just how important it is for researchers and practitioners working on ag and food systems to think beyond these important issues to also address health, ecosystem health, and zoonotic disease outbreaks. And I think it's really important to see this type of integrated work as mission critical rather than mission creep in our organization's work. So 3 brief reflections about how to integrate ecosystem health and agriculture, particularly with pandemic recovery and future pandemic prevention in mind. So the first builds really nicely off of Isabella's comments just now. We really need to push towards a much broader frame, a systems frame, and explicitly incorporate environmental and health externalities, including zoonotic risks, into ag and food systems research. Elements of an overarching question that I'll offer might be, how do we create more resilient and regenerative agricultural systems that provide nutritious food, reduce the health burdens of poor diets, combat climate change, and critical to our conversation today, reduce the types of practices such as deforestation and habitat fragmentation that are known to increase risks of zoonotic disease outbreaks. The second area then is really thinking about project teams and how we can help them feel empowered to pursue integrated research and solution testing. And they really need clear support and incentives from their organization's leadership that pursuing integrated work at the agriculture ecosystem health interface is valued and prioritized. And this can take many forms, but what really matters is that teams feel safe and supported rather than that they're working at the fringe and potentially their jobs or other opportunities are at risk, especially in these challenging economic times. So can we really center and really prioritize this integrated work and see its value? Third and final area I'll mention is just around funders and the really important role that they can play in driving more focus on integrated solutions. And part of this can be how they structure funding calls to really support testing and scaling of solutions that address the food, environment, and health linkages. And if what we need is stronger cross-sector action, then these funding calls can make that explicit by having metrics on each of the food, environment, and health components that compel teams to deploy a holistic problem-solving lens, being really explicit about what an effective solution looks like and how it addresses all the many factors that have been brought up by the various presenters today. So I'll wrap up and just reiterate that the COVID-19 pandemic really shines a strong, bright light on the need for integrating ag and food systems work with ecosystem health. Doing so is critical to preventing future outbreaks, but also alleviating poverty, combating climate change, and creating a more food secure and sustainable future. So thanks, Claudia. I'll pass back to you and look forward to our conversation.
Yep, thank you very much, Josh. I think your great points also to funders who continue to fund single sectorally. So if we just focus on yield improvements, how can we consider, for example, monitoring wildlife species that are often at these forest margins? Can we combine various interventions to achieve much larger outcomes? I think that's really sounds like a great idea. So now we come to our third and last discussant, Eva Olsen. She is a senior research advisor with CIDA. Eva, please do go ahead. Thank you.
Claudia, and thank you for inviting me. This theme today ties in very well with the discussion that we have started within CIDA on the implication for development cooperation fueled by the COVID-19 pandemic. As heard today from the many interesting contributions, encroachment on natural ecosystems give more opportunities for pathogens to spill over from wild animals to people, especially when the natural disease resistance that may result from rich biological diversity is lost. Land use and agricultural industry change, sustainable forestry, biodiversity, water depletion, therefore continue to be important research areas to focus on for the food and nutrition systems research. Also, we think it's important to strengthen animal health. This is for reducing the risk of pandemics and antibiotic resistance. We think that the One CGIAR should continue with the research for building back better and harnessing innovations to solve the complex global challenges. The CGIAR big data platform and the potential that AI has to improve the systems that we have talked about today seem like important areas. Of course, also to look on the risks related to AI with HR, with the human resources, with human rights and biases. At CIDA, we also think that CGIAR should go more local, meaning to use and to liaise with research systems in low and middle income countries, and thereby also strengthen the local research systems. Because it is the locally situated perspective that is needed in building back better, not least for policies for sustainable development. Excellent local research is also needed to inform the complex regional and global research, because we all need to be engaged in the solutions, although not everybody is responsible for the problems that we have come up. To talk what Isabella said that it's the research is behind schedule and everybody needs to be involved. Also the low and middle income country researchers and their systems. So thank you for a very interesting presentation, and I hope we have a good discussion. Thank you.
Yeah, thank you very much, Eva. I think great points. I think stressing again the importance of improved natural resource management to support, I guess, both food systems and ecosystem health, really taking this very integrated approach. And also we don't have, we have veterinarians on this seminar, but we haven't talked much about domesticated livestock health, but I think it's also very, very important component. And I think also that topic of digital technologies, artificial intelligence, what can we actually do here? Great points. And so now we are moving over into the discussion session, and we did get a series of very interesting questions, and I'll just start to mention those questions and identify respondents, but please let me know if you would also like to respond to the same question, either through our small chat box here, or you can just raise your hand. While we are doing that, please, audience, feel free to add additional questions. So we haven't closed the taking on questions. But let me start here. We did get some questions for Ricky for his presentation. And I think there's 2 or 3 that are in part clarification, but in part also directly linked to COVID-19. So the first one is, Ricky, you focused on croplands, but how does this link to land that's being used for livestock production, so which is more grazing and pasture land? And that's a question from Max Hill, who is a master's of public policy and management at Carnegie Mellon University. So Ricky, your analysis, how does it link to livestock production, because you specifically talked about croplands? And let me also just add another question from Caroline Beck at McGill University. So her question is on ice-free land, because also you refer to ice-free land. Is all of that suitable for crop production or animal grazing? Ricky, please, for you to answer.
All right, so this is now putting us deep into the weeds of the modeling. So the short answer is that I am not directly considering pasture land in my model at the present time. That is primarily for practical reasons, that it is very difficult to figure out where pasture land is and what exactly pasture land is, because depending on the definition, pretty much anywhere that an animal wanders through could be considered to be pasture, or all the way to intensively managed pastures that are with irrigation and everything else. Additionally, over time, the official kind of administrative unit reported data that's been reported back to, say, the Food and Agriculture Organization shows that to be fairly stable and almost even declining over recent times. And so that combination of things makes it very tricky to model. And so hence I have explicitly stepped around that, as you noted, by my concentration on cropland specifically. As to, now I'm trying to remember the other question. Oh, the difference between ice-free land and just general land. I am trying to consider all the land that I have good data for. So basically, I need to know what the soil type is and the climate and stuff. And pretty much what I mean by ice-free land is I'm excluding all of Antarctica, and I'm excluding, the vast majority of Greenland. And then everything else I'm considering as possible for crop production, and obviously for the other natural land types. However, again, defining what suitable land is, I happen to live in central Illinois, which is, one of the fantastic breadbaskets of the world. But humans are very ingenious, and they cause deserts to bloom and everything else. So it's about which places are kind of better and worse. The Sahara Desert without irrigation is a terrible place, but if you have irrigation and a little bit of fertilizer, you can do amazing things. So this is then where the economic modeling comes in to say, okay, well, where do people actually want the food, and what is the relative suitability of different places under different production systems?
Okay, thanks. Let me first move on to a different area of questions, and that relates to plant-based diets. We did hear, I guess I made that opening comment as well, but I think Isabella also mentioned dietary change, and Catherine, of course, focused actually on improving animal source food status of children in her presentation. So there is a question from Jenny's Cox that I'd like to pose to both Isabella and Catherine. What about moving towards predominantly plant-based diets? I mean, would this address all these environmental, resource, and pandemic concerns? So if we would just make this switch, would we be done? And actually, should we be doing that? So I don't know who wants to start, Catherine or Isabella? I think Isabella, you're going ahead.
Yeah, I can jump in. So I think that there is a bit of a challenge with the transition to wholly plant-based diets. Meat products and meat diets are still extremely important for many poor people in developing countries and low to middle income countries. And so making a radical transition would not be wise. And I think we saw that in the response to the Lancet report published by EAT, the EAT Lancet report. And we're not quite ready for that. However, that doesn't mean to say that we shouldn't be looking at alternatives and moving towards, as I mentioned in one of my first points, is increased dietary diversity and beginning to modify and adjust the farming systems towards more of a win-win situation where you have some more nutrient-dense foods, more fruit, more vegetables. Of course, there are trade-offs associated with that with regard to water management and irrigation needs. But also, and I'm about to hand over to Catherine because I think this segues into Catherine's points around the potential for cultured proteins for low to middle income countries. And obviously she raised some challenges there, but let me hand over to Catherine to speak further on that. Thanks.
Great, thanks. Well, I think our questioner has raised a really interesting point. And I think the short answer is yes. If everybody moved to a plant-based diet, it would be probably a lot easier on the planet. We're in conjunction with the work that we're doing with the cultured proteins. We also were looking at an analysis to look at plant protein quality, and that's also going to be published coming up. I didn't mention that earlier, but I think the reality is, as Isabel said, you can't just force people to start eating a diet that's better for them. You really have to you think about the way that markets drive the food system, and the food system is completely in the hands of the private sector, whether you're talking about a smallholder farmer or the ADMs, the supermarkets to the world, sort of, they're all of that is the private sector, and consumer demand is really pushing what's being brought into the market. So demand creation for better quality diets, and maybe ones that are also better for the environment, is an area where IFPRI could really, take a leading role, as well as some of the rest of us. But I think we have to be realistic with how the food system works and how consumer demand works, and that, having more on offer and thinking about the role of new technologies and, things that would allow us, for example, to reduce food waste, to produce things with a lower carbon footprint, to things that are, more nutritionally appropriate for diets for people, are all important factors when we're thinking about what is this next generation of food systems in the context of meeting the requirements for human growth and development, as well as being maybe more gentle on the planet.
Great. So I actually want Chris and John to also tell us if they think a plant-based diet is the solution for pandemic risks such as zoonotic disease risk. But before we get to John's and Chris's responses on that, there are actually two additional questions that came in on cultured proteins. So I just wanted to quickly bring those up. The first one is, actually there's three. So one is Sylvia Kaufman. She has a question to Catherine. Are cultured proteins already under development or on the market? And by what share could they replace meat? And I think Catherine will respond that the focus of this particular study was more on milk and eggs, but obviously there are also studies on meat. The other question is, why are we focusing on cultured proteins that replace livestock products? Why not just transition to plant milk? So that's a question by Maynard Clark, who's the executive director at Vegetarian Resource Center. So he basically wants to know, how much more culture does plant meat need to become, I guess, before we switch to plant-based milk products rather than cultured protein milk products. And let's see, was there another question on cultured proteins? I thought there was, but I don't see another one. Yeah, so those two questions to Catherine, and then I'd like to quickly hear from John and Chris, who directly work on pandemic disease risks, zoonotic disease risk, what their thoughts are on plant-based diets. Thank you. But first, Catherine, on cultured proteins, please.
Sure. So, this broad rubric of alternative proteins really has a whole slew of things that's included in it. So you have everything from complete plant proteins to ones that are hybrid, for example, like the Impossible Burger, which has a heme that's added to it, that's kind of, but mostly plants, to these sort of cultured proteins that are produced through fermentation, to proteins like meat that you could grow, I call it farm raised, PHARM, as opposed to FARM raised, that allows you to grow muscle in or tissue in culture. And so what's on the market right now are the ones that are produced through fermentation. So these are the ones that are milk and egg proteins, and those are likely to be on the market because it's an easier technology. We've used it for all kinds of things to develop vitamins and minerals. A lot of them produced that way. Even vaccines are often produced in that way. So it's a technology we know a lot more about it than the technology to grow actual meat cells. That being said, those products are going to be on the market probably within the next 5 years that are going to be at a price point where consumers can afford them. And the question about why not just go to plant-based milk, I mean, I think that's one substitute. The reality is, though, particularly for young children, the data seem to indicate that human growth and development really does need these complete proteins. And there are very few plant proteins that actually do that well. And again, we're doing an analysis on that right now. That's going to be published probably within the next few months. But the demand from consumers is what drives food preferences. So, it's not that you can just put things on the market and say, okay, everybody start eating this. You really have to work on the demand creation in order to change the way that people perceive their food preferences and the choices that they make. And so I think the solution set is to really have lots of options and to start to shift the way that people think about their own diets and food in terms of nutrition, the environmental footprint. Some people are thinking about animal welfare as some of the issues that they're thinking about when they're making food preferences. And helping people understand what those trade-offs are, I think, is part of the job that we're all trying to do when we're thinking about shifting priorities for food systems.
Yeah, thank you. So now over to Chris. Is plant-based diets the first intervention or one of the key interventions you would advocate for, given everything that you work with and see on zoonotic disease risk? Please, Chris.
Yeah, thanks very much for the question. I was really wanted to answer that as well, because one thing that we have to be really clear of, that of the habitable land on the planet, some 100 million square kilometers, 50 million of those are used for agriculture. And of that, 77% is used for pasturing or feeding livestock. So the largest land use change on a global scale is to produce animal protein to produce livestock. And that only constitutes, I don't know, some, 18% of all the calories at least that are produced. So there's this really disjunct, and this land use change is what is driving obviously conservation impacts. It's obvious, it's causing deforestation on a broad scale. But as we shake up these forests, the pathogens do drop out, basically, putting it very simply. And we're causing these large edges of destruction where spillover events can happen. Remember, once you've deforested and put asphalt in, it's not a problem anymore. You know, it's gone. It has a lot of other problems, but from a disease point of view. But it's this mix, it's this edge. This is what you're worried about. This is what John was also talking about. So yes, we need to change. There is no way around it, be it for pandemics or climate change or something. We need to change the way we consume animal protein. Obviously, it's not going to happen overnight. And there are obviously, as Catherine has pointed out, some very good reasons to eat complete animal proteins in some scale. But we need to move there. There's no way we can sustain this moving forward.
Okay, thanks. John, please, what's your...
Very interesting stuff, actually. Let me just start by saying that we've got to divide the world into different sectors and areas, because we can't apply the same solution to North America to what we see, for example, in the forests and the tropical rainforest in Africa. Plant-based, to get people that have relied on wild meat for millennia to suddenly start changing and eating only plants and all that is unrealistic, and it's not going to happen in the near future. We talk of about 5 million metric tons of wild meat that comes out of the Congo Basin alone to feed the huge number of people that are there. The growth rate of about 3% per year. And of course, I don't think it is realistic to actually advocate plant-based solutions to that, simply because we will be destroying more forests as we try to provide sort of the alternatives, let's say alternative plant protein for people who rely on the wild meat that comes out there. So I think it's extremely, and I think all of you have said it to some extent, that we have solutions for different situations. Middle income, high income countries can perhaps turn to plant-based diets much more than they do now, because they have the resources to be able to do it. But I can tell you, the Baka pygmies that we work with in southern Cameroon, it's going to be very difficult to get them to produce enough plant food, and do they want to do that anyway, to be able to have a healthier long-term life. So, and that comes to the whole issue that has been debated recently, whether we should be stopping people from hunting or stopping markets. I understand that urban markets, like Chris says, is possibly the main source of infection all over the world. But to actually advocate stopping people from using the resources that come out of forests, because we in the Western world believe that is the solution to our problem, that is not the way forward. So I think we need to parcel the way that we're going to deal with the overall problem of food security. And I think we have to, and again, we've mentioned it, we've got to understand the needs and aspirations of indigenous peoples, of rural people that still rely on wild meat as a source of protein and micronutrients.
Okay, thank you. There are also a couple of questions actually focused on forest land, and they're directed at Chris and John, and I think to some extent also to Ricky. So let me start with those. Katie Kane is asking, how can we support indigenous land stewardship and prioritize food forests as a global community? So that is the first question. The second question by Moat Lodi Pitze, who's a development student and resource mobilization practitioner, has a question on the role of indigenous communities. I think we've just heard from John about that. So the point is, for centuries, indigenous communities have successfully coexisted within a complex ecosystem with little disruptions. And so, why has this changed? Is it the very high consumption levels and high demands of, I guess, the richer part of the world that has introduced unsustainability into the system? Or what is it? And I think I guess two more questions are more generic questions. One is, how much forest cover do we actually need to sustain our population, and where should these forests be located? I don't think we can move them that much, but that's a question from Cecilia Akin. Yeah, so if you could maybe address those, and then we go over sorry, the last question from Professor Shankar Chatterjee from India, originally to Ricky, but I think it might also be good to address by John and Chris, is forest fires. What's the role of forest fires? They have been obviously very damaging. What are the consequences, I guess, again, also for zoonotic disease risk, and again, what can we be doing about it, again, from an agricultural food systems perspective, but I think also overall. So there is the land stewardship component. What's the role? Then there is the indigenous communities. Why are things not as they were before? And then also forest fires. So I don't know, John or Chris, who wants to start?
I can start, and okay. Chris can follow, if you don't mind, Chris. Let's talk about indigenous lands and all that. The recent study that we've done, with Stephen Garnett in Darwin University, we've shown that about 40% of the land, and certainly about 30% of the intact forest lands, are actually managed or in some sort of way by indigenous peoples. So indigenous people throughout the land, especially in forest areas, are incredibly important guardians of what's going to happen in the future. We don't know, sort of the analysis that we're doing at the moment doesn't actually take us as far as saying how much of that land is being used to supply the food security needs of these people. But obviously, these lands have provided these indigenous people throughout the world with enough food and shelter and materials for millennia. So I think it's extremely important that we as an international community take on board the needs and aspirations of indigenous communities throughout the world, because they are custodians of about 40% of that land and incredibly important for the conservation of biodiversity, as well as sustenance for these communities. So I think we mustn't forget that. We've got to take that into account. What has changed? For example, we can tell you what has changed in terms of use of wild meat. And what has changed is the fact that we have these burgeoning urban centers in developing countries, in tropical rainforest areas, that are demanding animal meat that comes out of the forest for whatever reason. And we know that out of that 5 million metric tons of meat I talked to you about before in the Congo Basin, a very large portion of that is being taken to cities like, for example, Kinshasa and Brazzaville and many others, and consumed there for no other reason that most people don't need that protein to survive, because they live in better conditions than rural areas. But things have changed dramatically, because all this meat is being taken out of the forest by commercial hunters, or even by rural hunters that suddenly believe that they can make a lot more money by sending meat to the urban centers. So the whole system has flipped over, lots of, we've, with WCS, we've finished up some studies in Kinshasa and Brazzaville. And there's an enormous amount of meat still coming from the forest into those cities for, degustation of the urban dwellers. And I think that's a major issue. It's a major issue because of what Chris said, that we are bringing all these animals together, domestic as well as wild animals. There is a potential of disease outbreaks, but also because we are depleting the resources that rural and indigenous peoples need in the forest to supply the whims or the taste of urban dwellers that don't particularly need it.
Okay.
Yeah. If I could just add to that, Claudia, is that all right?
Yep, I think
so. You know, as John has really already clearly put out, it's first of all, it's all very context specific. So that's the first thing. And these urban centers which are draining the forests, I mean, it's just not possible anymore that some of the cities which used to have 3,000 inhabitants now have 30 to 300,000 and still relying to 80% on wild meat to meet their dietary needs. And that's just got to be changed. That's got to be changed by demand reduction and providing alternatives. That's why I'm really great to hear what Catherine is working on. It's not all going to be invertebrates. We may need the cultured proteins and other multi-pronged approaches to that. And then beyond the Congo Basin, of course, we have this massive market in Asia, which is really providing status symbols and luxury items. You know, eating a pangolin makes no sense. It's really expensive. It comes from God knows where. I don't want to, the poor pangolins, there's nothing to do. It's not their fault, of course, but they're just the epitome of a status symbol. There is no nutritional need to eat pangolins. These kind of things need to stop. And the big difference is as well in Asia, the animals are alive on the market. So that really allows for recombination events to occur. Once it's dried and smoked and so on, the risk is so much lower. So, you know, if you eat a dried chimpanzee, that's not a problem. It's butchering the chimpanzee, which is going to be the problem. But once it's dried, there's hardly a risk there. But if you put that chimpanzee with a pangolin and a chicken and a few pigs there, that's when you're starting to get interesting recombination events. So I think we need to keep these things apart. And we also need to stop using a romanticized version of indigenous peoples and local communities' needs. I mean, this is people sitting at universities in ivory towers making statements about what's going on in the forest. I like to hear what John says. John is there, he knows what's going on. WCS is on the ground, we know what's going on. This is not Baka pygmies going out hunting. They're not the problem. The problem are the 5 to 8 million people who still want to eat bushmeat in Kinshasa, in Brazzaville, and the other cities. So we need to stop obfuscating the problem by waving up this thing. We need to protect the needs and the rights of indigenous people. That is absolutely true, but let's not misuse that.
Great. Yeah, definitely we've never talked so much about bushmeat in an IFPRI policy seminar, I believe, because in terms of overall food supply demand, it's a very, very tiny share, but a very risky share, as we've certainly learned. I'd like to move over to some other questions. Actually, going back to Ricky's presentation, he used the word warlock plan, and that brought a couple of comments. So Anne Tutwiler from former Bioversity mentioned, won't going back to the Borlaug plan possibly exacerbate biodiversity loss, including agrobiodiversity, and will it not threaten soil health and water quality? At the same time, Dr. Ajay Singh from IIT Kharagpur, India, mentions in relation to the Borlaug plan, minimizing forest disturbances is a good idea, but is the Borlaug plan of better yield sufficient to feed 10 billion people in 2050? And I think related to that, Keith Wiebe from IFPRI mentions, Isabella, can you please say more about the nature of modern approaches to sustainable intensification and agroecology, which links to the Borlaug plan, but is maybe a modern interpretation of the Borlaug plan? At the same time, there are 2 GMO questions that I think we can bring into the same set of questions. One by Josephine Love. Looking at GMOs, what do you think would be the effect of the land, water, or I guess effect to the land, water, and ecosystems from GMOs? You know, are they good for land, water, and ecosystems or not? And I guess the question specifically is directed at IFPRI, but please, anyone who would like to comment on that. And there's also a question about the GMO component in cultured proteins, which relates back to Catherine. So a lot of issues around on the productivity piece. So productivity focused on reducing this forest disturbance. You know, how should we be doing it? There's a GMO version of it. There is the modern agroecology piece of it. Is it even enough? And will it actually support ecosystem health? So maybe let's start with Ricky, because he put that board plan into his presentation, please.
Hi. So, I come at this as a so-called global modeler, and so my perspective is to try to create the context, and so we need the people on the ground, and I'm the pointy-headed person in the ivory tower pontificating about what's happening from far, far away. But I wish to underline the point that, you know, the indigenous people doing their thing may be good, may be bad, but it's not the problem at the global scale. So worrying about whether they are, whatever they're doing is not that big a deal. Again, because when we look at the global scale, the world is a really big place. And the problems that are being caused are when we have the tremendous numbers of people, and then we don't always do things in an efficient manner. So yeah, the Borlaug approach, the Borlaug hypothesis was the idea that, hey, well, if we can increase the productivity of agriculture enough, it won't have to encroach on the natural land so much. And it had its place. I think it's an important thing. It's the general concept I think is good, but I think, as I said before, I think it needs to be conceived of more broadly within the policy context of it's not just about food, it's about other kinds of non-agricultural opportunities for people to live happy, prosperous lives. But we also have to have a broader view within agriculture of exactly what that means. It's not just about, tearing everything apart with bulldozers and completely rebuilding the soil and bringing in completely new monocropping and pouring tons of fertilizer on it. I mean, this is the cartoon version of it, right? We have to think more broadly about how to do that. Now, as to what the limits of that are, the limits of that are that even if we, in that little thought experiment I did with the land use model, hey, even if we completely pulled back from any land that we would reasonably expect to be in forest, even if we imported all that food from the moon, we still might not get back to where, as the climate changes, we may not get back to where we started and what we were used to. So there is still a lot of, so no matter what we do with agriculture, we still have to manage the climate and the way that we humans are interacting with the climate. And we're going to have to think forward to how things are going to change in the future, because even if we completely erase the agriculture interface with forest, if climate change is changing where the forest is, it's creating new interfaces that are not just localized, but will be pervasive. So no matter where you go, you'll have that kind of shaking and the possibility of conflict and disease and everything else. So I will stop and allow others to comment now.
Yeah, so Isabella, maybe on the modern interpretation of maybe agroecology, and which is, I guess to some extent a modern interpretation of the Borlaug plan that wasn't that specific. It definitely focused on seed technologies and yield growth. And also if you want to comment on GMOs.
Yeah, thanks, Claudia. So, I mean, just to remind everyone, of course, Norman Borlaug said that his model was a temporary solution, and we're still working with it. How many decades later? 20 or 30? So what do I mean by modern approach to agroecology and sustainable intensification? So I think it's about it being unbiased and not romanticized. I think we've heard a lot about that already with regard to indigenous communities. I think we've romanticized some of these approaches, whether it's agroecology, conservation agriculture, climate smart agriculture, without really fully considering whether these approaches really function effectively and are economically efficient for smallholder farmers as much as delivering on environmental and sustainability grounds. So I don't have any sort of magic answers to this, but I think we also have to recognize that these areas have been severely underinvested. And so how on earth can they compete with some of the other agricultural models? And let us hope that we are seeing a bit of a shift and a turn in the tide. So, you know, what, in conclusion, what would modern agroecology and sustainable intensification be to me? Engaging with the South and understanding what Southern priorities are, not from a romantic perspective, looking across the whole continuum from the more green conservation type approaches right through to GMOs, and also looking at how you bring in some of the new tech into the South in a way that brings in new opportunities for youth, and that doesn't disadvantage and create new inequities, whether that's vertical farming, cultured proteins, which we've been talking about today. So GMOs, not really my area, but yeah, there's again been fraught with political, highly politicized debate. And can we move forward from that and really kind of clear the decks and look at what is it about GMOs that functions effectively, and in which context can we be applying GMOs? We don't have many technologies that can feed a growing population rapidly and in a way that does not cause more deforestation. So we have to look to something pretty fast. You know, if you look at some of the projections for Africa and yield increases for Africa by 2050, it's staggering. It's absolutely staggering. So yes, we do need to look at GMOs, but let's clear the decks on that and get some sound evidence and independent views on that. Thanks.
Yeah, thank you. We only have 3 minutes to go. I agree with Isabella. GMOs have actually really helped yield growth while reducing pesticide use, often applied by women, many other positive benefits, but because of regulatory and other challenges, also many political and other challenges. But let's go to a 30-second per person closing statement from all of our speakers, and we just start with the same list from speakers to discussants, just in 30 seconds, like 3 words. What should agriculture and food systems do differently to address pandemic disease risk? Please, let's get started with Chris, but just 30 seconds, please.
Sorry, I was actually distracted. I'd have to pass. Sorry, I was just distracted for a second.
Yeah,
My apologies.
Fine. That's fine. Ricky, please.
Well, as we've been discussing, disrupted ecosystems, I think, can lead to the transfer of diseases between people and animals. And by definition, agricultural production displaces natural ecosystems, because we just kind of define natural ecosystems as what would have been there. Climate change is also going to be very disruptive, but these happen at very different scales. Cropland expansion is a rapid, intense, localized process that brings people to the animals, whereas climate change is a slow, broad, diffuse process that brings the animals to the people, in a sense. Both will need to be dealt with, and I think both are going to require international collaboration to figure out what's really going on and what we can do that would be useful to help.
Thank you. That was a bit longer, I think. John.
I'm going to try to be 30 seconds. I think it's vitally important that we all bring all of our resources together, that I know this may sound again very romantic, but we've got to work together, the agricultural front or the people working in agriculture, with those of us working on forest and ecology and so on. I think it's fundamental that we do that. I don't think that divide and conquer like we have been doing, frankly, in the past is going to be the way forward. One Health approaches are fundamental. Let's do that.
Thank you. Catherine? You're muted. You're muted.
I think we're in a very exciting time. We have an opportunity to rethink the way that we look at problems and how we think about solutions, and multi-sectoral thinking and looking at these in a concerted way where you're getting nutritionists together with agriculture people, together with environmentalists, is really the wave of the future in terms of problem solving. And it's very exciting to see how that's playing out. And certainly the Bridge Collaborative, I think, has been a really instrumental organization in terms of thinking about how we can start to make those connections among people.
Great, and I'll move right to Josh because we just heard from Isabella. Josh, please, any final quick statement?
Yeah, well, really, sort of echo others, just saying we're faced with two escalating and urgent issues. It touches everything we do in agriculture and food systems. So it's the zoonotic pandemics, it's the current one, it's reducing risks of future outbreaks, and it's climate change. And these really require us, as Catherine was just saying, to take an integrated look. It's got to be across food, environment, and health in every project we do. And we really need the leadership and funding incentives to make that integration possible. But if we can do that, I agree with Catherine. I think we can move really importantly and quickly in this direction to get this work done. Thanks.
Great. And Eva, as a very last word.
I have to lobby for more resources to modern nature-based solutions, especially in the South. Thank you.
Yeah, thank you very much again to all of the speakers, all of the discussants, and to our audience that has been very active. We were not able to address all of the questions, but the stimulating discussion and the questions will really feed into the CGIAR research of the work that everyone is doing, both for food systems and to address zoonotic disease risk. Thanks to everyone again. Very inspiring discussion. Thank you.